Hello and welcome back. So in this video, we're talking about the third part of this series on asset registers and why they're important to ICS OT cybersecurity. So I appreciate you for coming back, and we'll go ahead and jump into this section where we're talking about active scanning, where we're putting network packets out on the network to reach out and find what types of hosts or assets exist in the environment. And we can also not only just find those live hosts, but we can see what types of ports are exposed on those hosts and what services or applications are running on those hosts as well. And so that would be one way that we can look for different assets in the ICS or OT network. We want to be very careful though to when we talk about active scanning that we're typically not talking about conducting active scanning, again, putting network packets on the actual network at lower levels of the Purdue model. This is where we can run into trouble with crashing systems, right? Or making them at least maybe reboot to cause some type of issue within the facility, which could lead to potential other consequences that have serious repercussions, like not only physical safety, right, but environmental safety and making sure that the facility stays up and running. So we want to make sure that anytime we're doing active scanning, right, we're doing it in an authorized manner, that we're doing it in an extremely safe manner. So we'll typically look at doing active scanning at higher levels of the Purdue model, even in the OT environment where we see nowadays more like traditional IT assets running Windows. And so, and kind of jumping ahead. So we'll get into all of this. But when we talk about active scanning, okay, this is where we use a tool like Nmap. Nmap comes from, if you want, the IT world, but it was simply designed as a tool to reach out onto a network to see what's out there. And again, find those assets. And not only just those assets, but what's running on those assets. I used Nmap for a long time in IT just to test connectivity through firewalls, which is a great tool to be able to do that, especially if you're troubleshooting, let's say, connectivity between the ICS and OT networks, between a DMZ. It's a great tool for that. So it's not just about using it as a cybersecurity tool, but at the same time, it is one of the most popular, if not the most popular, cybersecurity tools that we have in the world. And that's what we're going to look at using as a tool today for doing active scanning. But again, we have to be careful on which networks we're performing active scanning on. In most environments in the IT network, you are scanning pretty much as often and as fast as you want, whenever you want. In the ICS or OT network, and that's very different. That's where we come back and look at, we'll probably look at being able to scan those higher levels that run traditional Windows uh, systems, like in the DMZ, or when we look at the higher levels of the OT network just inside that IT to OT DMZ, that we can see those Windows assets. But as we get lower into the Purdue model, looking at the network, when we look at PLCs, maybe HMIs, even if some of them are running Windows, RTUs and so on. The idea is that again we could cause an issue with one of those systems, especially older ones. The older ones don't have the ability, they don't have essentially the troubleshooting code built into them that if they receive a network packet that they don't understand, where they can just disregard it. A lot of the older systems, where they get those packets that they can't understand, essentially they choke and have to be either rebooted or they completely die to where you have to completely replace them, which is not what any of us want to have happen, especially in a control system environment. So again, make sure we're doing this with authorization. It is scheduled in the control system side, and that we're again, more than likely just looking at those higher levels of the Purdue model. So you mentioned Nmap's going to be the tool that we're going to use, and this is the main tool that just about everybody uses. And you see, it was created by Fyodor almost 25 years ago. So Gordon Lyon, who goes by the name Fyodor, right, created Nmap, and you can find it at insecure.org, which is a great site. He has a lot of other resources that you can find there as well. But of course, the main reason I think people go there is to be able to download the latest version of Nmap. Nmap runs on just about anything and has for a very long time. So you can run it on Windows or Linux or Mac or your phones or a Raspberry Pi and the list goes on and on and on. They've even found it in the entertainment systems and dashboards of luxury cars like BMWs and Mercedes-Benz, which I always find kind of funny. So there is a graphical interface you can see there called ZenMap. I'm not necessarily a fan, but hey, to each their own. I completely understand if somebody prefers the GUI interface, especially in maybe when they're just starting out with network scanning and need that actual visualization. So, and then you can see as of the moment, I think it's still July 2023. The current version is 7.94, so maybe coming up on a major release coming up soon. So, and I do have a couple of quick start guides available in my GitHub repository, which you can find there at the link. So we actually have one that I created just for Nmap in IT in general, and then one that I created more specifically for ICS OT environments that kind of hits the highlights of what we're talking about here. And here's an example of the one that I created for IT. So it gives you an understanding of how to do things like run a ping sweep to find hosts with ICMP, or how to do an ARP broadcast, which we're going to talk a little bit more in this section. They talk about how fast do we want to scan, how slow do we want to scan, right? How we can scan all different types of networks and the different types of scans we can run. And then it also gets into service and script scans, which honestly, that's the more fascinating, the more fun part of using Nmap, even though we're not going to realistically get into that in this discussion today, unfortunately. So that'll be a different video for a different day coming soon. But there's the Nmap Quick Start Guide for IT, and then here's the version for ICS OT. So some of it is very similar, and at the same time, though, it also has a strong focus, as you might imagine, on control system environments. So you can see, especially in the middle, where we talk about things like, oh, here's a list of the most common ICS related protocols, like Modbus, which we're going to look at today. Right? Modbus doesn't show up in a default Nmap port scan. It just doesn't. It's not one of the most commonly used protocols in the world. It is the most commonly used network protocol in control system networks. It's just not on the top 1,000 list of common protocols on the internet, which is probably a good thing. So when we talk about scanning, right, active scanning, we first want to find out what assets, what hosts exist on the network. And then from there, once we know something's out there, well, we want to determine, well, what the heck is it? So we can start to look for, well, what ports are open on that device? Because sometimes even just seeing a open port on a specific port number, which we'll get into, can give me an idea of what's running there. Like if I see TCP 3389 is open on a target system, that is almost always 99.99% of the time used for Windows Remote Desktop. So in this case, I know, oh, that live host that I just found, it's running Windows. Again, I might not know its purpose or its intent, what it's doing, but I know it's running Windows. What we can do is we can do additional checks, though, when we find those open ports to understand what types of services and applications are running on those ports. Because if I see something like, let's just say port 21, which we can still see not only in IT, but sometimes in control system networks. And port 21, TCP port 21, is used in FTP, or the file transfer protocol. Well, it's good to know, okay, there's FTP running on that system, but, well, what type of FTP? Who's the vendor, right? What's the software version? Because once I have that vendor and that version number, that's when I can also take that and map it out to any potential vulnerabilities that are on the system. So when we talk about asset registers, and yes, they're important to operations and maintenance of the facility, undoubtedly. But of course, what I'm wanting to use asset registers for is this basis for understanding what's in the environment and, more importantly, what vulnerabilities exist in the environment that we need to be aware of and that we need to address if we can, or be able to deploy compensating controls to at least limit the risk associated with those vulnerabilities. So here's a quick example, though, of using Nmap as a quick tool. And let me go ahead and grab a command prompt. And I can go ahead and put this right there in the middle. And oh, I better check for what my local subnet is. We actually just replaced the cable router through the company. So let's look at. So my local subnet is 10.2.1. So I'm going to do and then just go nmap.10.2.1 and then 0/24. So if you're not familiar, that's what they call CIDR notation, which means scan for all 255 possible hosts, really 254, but scan for all of the possible hosts on this subnet that starts with 10.2.1. In this case, I'm just going to do the -s, lower s, capital P, so dash lower s, capital P, and that's going to do, at a high level for now, we'll say it's going to do a ping sweep. So it sends out an ICMP request, a ping, to see, hey, are you out there? And if it gets a response back, it says, okay. And we can see, oh, it looks like Nmap found what, 1, 2, 3, 4, 5, 6, 7, 8, 9 different devices on the network. Now, one thing to note behind the scenes, and we talk about this in later sections or other videos that I'll be doing as far as using tools like Wireshark to watch at what's going on behind the scenes. Because if you actually do an Nmap ping sweep on your local subnet, it doesn't actually send out the pings. It doesn't use ICMP. It actually uses ARP because it's a much easier method of detecting systems when they're on the local subnet. And that's what we had actually talked about in the last video in the series. So hopefully you remember the ARP section. And so we use ARP by default if we're talking about the local subnet. But if you talk about, so meaning my laptop is on the same subnet that I'm trying to scan. If my laptop is trying to scan any other network in the world, it'll use ICMP for that ping sweep. But in this case, we found 9 assets. And you can see some of these actually have names. And we started to touch on this in that last video as well. Because remember, we can take the MAC address, that 48-bit address that we have assigned to the hardware on that remote host. We can look that up in the IEEE MAC database and see what manufacturer is associated with that. And I can see, oh, there's a Roku. So there's my smart TV. I see a lot of unknowns. These are probably mostly our iPhones, which, and with Apple always randomizing those MAC addresses when they join a Wi-Fi access point. So that way you can't determine what they are, where you used to see something like Mike's iPhone. But that's the idea of how we can do an initial ping sweep to find what assets are out there. Again, this is one that is more than likely safe at higher levels of the Purdue model, but as you get lower, it's not necessarily always safe, even if we think, oh, it's just an ICMP packet. Again, if those remote hosts don't understand, especially the older ones, don't understand how to interpret that incoming ICMP request, it could crash, it could die, you could brick it to where you have to replace it, and that's not the type of day anybody wants to have. So when we do a port scan, and the idea is, I always think about, a lot of people always think about in terms of, if, let's say I'm a thief and I want to break into a house to steal something, right? Just to sell it and make money. Right? I'm just after the quick cash, like a lot of cyber attackers are. I can drive through a neighborhood and I could look to see what homes might have the garage door open, or whether a window is left open, or whether a door looks locked or not. And it's very similar where we're, instead of course, scanning for houses, in this case, we're scanning for those active computers that are on the network. And then every time we find a port on one of those systems, it's just like having a window or a door into the system. Right? Because if we have a application or a service running, like if I have a web server, we see these on HMIs these days. I might have an HMI that runs a web server, which is that which where it's displaying the actual graphical representation of the assets that it's controlling. Well, that web server can run on TCP 80 or TCP 443. The idea is that there could be vulnerabilities. Maybe those windows that are there, they're not locked. They're not bulletproof glass. Maybe they're wide open. And that would allow the thief to come right into the house. Or in our case, maybe there's a vulnerability in those ports that allow us to come right into the system and take full administrative control. Now, in each asset, and these we're talking about the ones running TCP/IP. So I realize completely that not all hosts in the control system world run TCP/IP, but most at the higher levels do. And this is where we're going to start. And so every host running TCP/IP has 65,535 TCP ports and 65,535 UDP ports. And there's some general rules about how those ports are assigned. Uh, we take those with a grain of salt. There are some common ports, like we mentioned earlier, TCP 3389, and we know 99.99% of the time that's used for Microsoft Remote Desktop. It doesn't mean I can't put a web server there, or a FTP server there, or a Modbus server there. It just means that that port is normally associated with a certain service or protocol. That's what they call about those well-known ports. And then again, everything else is pretty much up to us. So we talk about port scanning. I think if you're not familiar with the concept, you're probably starting to get a good idea at this point, at least hopefully, right? Where we start to look for not only those computers or those assets that are in the environment, but we want to find what open ports are there, right? What windows does the house have? And then we can start looking more closely at those windows to see, again, are they locked? Maybe there's a glass break sensor there or some other type of sensor. If we open that window and there's an alarm on the house. So we think of things like intrusion detection systems in the network. So we want to be able to find those ports to determine, right, what windows exist or what doors exist to allow us to break into that system. So I do want to take a real quick talk about the differences between TCP and UDP. And there's a lot of slides in here. We're going to go through them very quickly because I have a much more in-depth Nmap workshop that I'm going to post. But I did think it necessary to understand the differences between TCP and UDP. With TCP, this is where we have an established connection between two systems that want to communicate. We always liken it to if I want to send my mother a birthday card. If I get that birthday card, put it in an envelope, I get a stamp, I put my information on it, I put her information on it. Most importantly, I write the destination of where it's going to, right? Her name, her home address, and I put it in the mailbox. And I pay in this case, the postal service or another company like FedEx or DHL or UPS, that I get a return receipt that I know that the envelope and the birthday card got to my mom, then that's TCP. It's a connection-oriented protocol. We have guaranteed delivery. With UDP, we don't know if the envelope or the birthday card ever gets there or not. Because I can put my mom's information and my information and stamp on the envelope and put it in the mailbox. But if I don't pay extra, I don't have that return verification or the delivery verification service. I never know if that card got to my mother or not. She lives on the other side of the country. So there's a million little things that could go wrong and prevent her from getting that birthday card. So when we talk about sending information between two systems communicating, we like the idea of TCP because it's connection oriented, right? There's guaranteed delivery. But because it's guaranteed delivery, well, there's overhead. And that overhead, what we call the three-way handshake, which we're going to look at in a second, it makes TCP slower. So if I'm sitting at home streaming Netflix, I don't care if I miss a couple of packets. I wouldn't, the human eye wouldn't see if we dropped a couple of packets while watching a TV show or a movie. We just want the data to get there as quickly as possible. So when we talk about large amounts of really inconsequential data, we can use UDP. It's very fast because there's no overhead, where we use things like the three-way handshake. And there's some other overhead in there. But the three-way handshake is where it all starts. And the three-way handshake is what Nmap measures to determine, is there a open port on a remote system, and what might be there potentially when we get into, again, service scans and script scans, but that's a whole other video. But this is an example. Again, we're just going to go through this real quickly. Just look at when I have, let's say this is me sitting at my computer and I'm testing this remote asset or the server. I'm going to send a SYN packet to one port and say, let's say TCP 80, the default port that a web server runs on, and says, hey, are you there? I want to talk to you. And the server, if it gets that packet, and if port 80 is open, which means something is running and exposed on port 80, then it should send an acknowledgement back to say, hey, yeah, I want to talk to you. I'm here. And at the same time, that only establishes a one-way communication. It allows my computer to send the server. It does not allow the server to send to me. So at the same time, the server will send me its own SYN saying, hey, I want to talk to you. And then I can send this acknowledgement back to say, okay, I'll talk with you. So what we do is we really need to send 4 packets originally, right? I need to send one SYN and get an ACK back from the server. And then the server would send its own SYN, and I would send an acknowledgement back. So we could have two-way communication. But instead of having a 4-way handshake, why don't we just merge 2 of those into one? And that's why you see the SYN, SYN-ACK, and INACK process. So again, for now, just that's the high level. And if you want to get more information on that, we'll definitely come back and dig much deeper into it, into the Wireshark workshop. And there are different packet flags. Again, these are more, again, when we're talking about SYN and ACKs, but there are other ones that can be used for testing, again, which we're not going to look at these. We're going to talk about things like reset real briefly, but again, we'll talk more about these in the Nmap and Wireshark workshops, mostly in depth. But when I'm scanning a remote host, typically what we're doing is what we call a SYN scan, which is really the process we were just talking about with the three-way handshake. Because if this is me and I want to test this remote asset, I send that SYN packet to port 8. Remember, I have to send a SYN packet to every port I want to test. So I'm going to send a SYN packet to port TCP 80 to see if maybe is there a web server, or what if I'm looking for assets running Modbus? So I can send a SYN packet to TCP 502 to see if Modbus is running on the default port on that asset. So I send the SYN, and if the server or that asset comes back and says, oh, it sends me a SYN ACK back, that means not only did my packet reach that remote asset, but it got a response back, and that remote access said, oh yeah, we're here. And you were testing port 80 or port 502, whatever port we were testing on. It says, yeah, there's something running on that port. And at that point, I have my answer. I send a SYN and I got an answer back, says, yeah, there's something running on this port. That's what we were looking for. So we don't even need to complete the three-way handshake at this point. It'd be nice if we did and then tear down the session nicely. But from a scanning perspective, again, I have my answer. Is something running on that port? And yes, the port's open. I got my answer. Now, in this example, well, what if I send the SYN and I send it, let's say, to TCP 80 to see if there's a web server running maybe on an HMI. And then the system sends me a reset ACK back. What this means is that, oh, that asset, that HMI in this case, it got my SYN request. And it said, hey, thanks for reaching out. but there's nothing running on this port. There's nothing running on this port. So thanks again. So we got the communication with the asset, right? It's talking back to us and it's saying there's nothing running on this port. That's where we see a reset acknowledgement request come back, which means, oh, the port's closed, right? We're communicating with the server. It responded back, but with a reset ACK, which tells us, okay, there's nothing on that port. Move on. The other instance is, well, what if I send a SYN and never get a response? And the idea is there's something, more than likely like a firewall, between us and that remote host that's blocking the communication. So if I'm just sitting there waiting for a response and I'm not getting anything and I'm not getting anything, then that's where we're going to see a port show up as filtered. So there's three options that we get. We see open, where we did a SYN ACK from a specific port. So we know, oh yeah, there's something running on TCP 80 or for that HMI or TCP 502 for Modbus on that PLC. We can also see if I get that reset ACK back, it means we're still communicating with the asset. There just isn't anything running on the port that we're testing at that one point in time. And then last, if there's that firewall between us and that asset, then we could not get anything back. In that case, we just say, oh, okay, it's filtered, which means, yeah, there's a firewall. Almost always. So Nmap, you want to remember, by default, scans the most commonly used 1,000 TCP ports on the internet. So not going to find a lot of industrial control protocols on the internet. Some, most definitely, we still see some, but they're not going to show up in the top 1,000 ports, which is one thing to keep in mind, because if you scan a host, like in this case, I scanned this remote host of 192.168.1.114, and it comes back. Again, it only scanned the most 1,000 common resources, right? If I go back to my Nmap and I just scan my local host, you can see, oh yeah, it's a Windows host. I see very common Windows related services that are exposed, like 135 and 445. And it even says, hey, there's 996 closed ports. And then, oh yeah, here's the 4 open. Remember, because we're scanning the most commonly used 1,000 ports on the internet. Fyodor actually scanned the entire internet at one point in time and used that data to create his list. So now, and while we kind of talk, I'm going to go ahead and run, well, let's run a complete port scan on my local host. So we're going to do -p dash, which says scan all 65,535 TCP ports. And now you can see, oh, I didn't just find 4 ports, but it looks like we found 24 ports plus 1 filter, which brings up a whole lot of interesting conversations, which we're going to touch on a little bit in this, and we're going to definitely talk a lot more about that in the Nmap workshop. But you start to get the idea that we have to look for the host first, and then we have to test the ports. Now, that result was very fast because I'm scanning my own local host. As soon as I start scanning remote host, even if they're on the same subnet, that's where things start to slow down. So part of the scanning process is determining, right, how fast we can scan, how often we need to scan. Right? It's quite a balancing act, especially at those higher levels of the Purdue model. So we talked about you can use -p dash to scan all of the TCP ports or all UDP ports. But because of how UDP works, there's no 3-way handshake to measure to determine whether a port's open or not. Sometimes it's very ambiguous, even if we get an answer, kind of, sort of. But so a lot of it is unfortunately a wasted time that we really don't have. So even if you are scanning for all TCP ports, you're probably only scanning for a few UDP ports. And we'll talk a little bit more of that before we wrap up this section. But here's another example of 2 hosts, just like we were looking at my local host, right? Where, oh, Yeah, you do a default scan where we're only scanning for the common 1000, you might, find some things. But if you scan for all 65,535 ports, then now you can see how many other windows are in that house to break in. And in this case, example on the local host, what if, oh, like I see 502 now when I'm scanning for all of the ports on my local system. And I can see, oh, more than likely, yeah, that is Modbus. And one thing that we weren't going to get into, but if I scan for just 502 and do a service scan, Nmap will do additional testing to see what's actually running there. 502 is usually used for Modbus. That's what this is saying up here. Well, even it's not even saying Modbus, right? We see MBAP, where now we do some additional tests and it actually comes back and says, oh yeah, this is Modbus TCP. And remember, even though you see TCP 502, there's lots of other variations of Modbus as well. But at high level, right, we have a Modbus implementation over TCP IP that we wouldn't have caught using the default scan, which takes me back to one of the reasons why I put that Nmap guide together for ICS OT networks. So you have a cheat sheet, essentially, right, to help you find those more commonly used industrial control protocols. So like I already mentioned real quickly, with UDP, there's no three-way handshake for Nmap to measure to see whether there's a service or application running there. So if you send a UDP packet to a remote system, right, if there isn't a receiving port, it should come back with this idea and with an actual ICMP packet, which is a port unreachable function. So ICMP is a whole suite of protocols. So we need to think of things like ping and which is made up of an ICMP request and an ICMP reply, then uh, there's another function called port unreachable. So we know we're talking with the asset. So it's good that hey, there's an asset there. And that it probably, okay, it means it's closed, but everything else, or if I don't get a response, it just shows open filtered, which again is very ambiguous. So we typically don't uh, measure many UDP ports. We'll just check for some of the commonly used ones. And those are again in the cheat sheet and the QuickStart guide for Nmap. Again, because part of the reason is because there's no three-way handshake, we sit and we wait a lot in UDP scanning to where the time to scan UDP is literally, 10, 20, 30 times longer, depending on the environment, than it is to scan TCP. If on a good day. so again, we typically will only look for certain UDP ports, not even the common 1,000, maybe a dozen, but probably not more than that. And we also have the option to scan an entire subnet like we saw earlier. So show me where on the network, right, I have hosts and all the open ports that are on those hosts. Okay, we'll get more into that in the Nmap workshop. If you're curious, hope come back and check out that video because I've had a lot of great participation and response for that when I've done it live over the years. And then in this case, here's an example where I like to use the -- open option. So if I'm scanning an entire network, let's say, I just want to find the Modbus instances. If I didn't specify open, what I would see is close, 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 maybe 100 times, and then one open. I'm like, you know what? I just want to see the opens. Don't show me all the close. Don't show me where I'm scanning other assets and they're not running Modbus. Just show me where Modbus is running. So that's the beauty of -- open that I just love to throw in there at the end. Because again, if you're scanning, especially a larger environments, then -- open comes in very, very handy. So that wraps up this part of the section where we talk about active scanning in control system environments. So I appreciate everybody. I appreciate you for taking the time to check out this video. And in the next section, we're going to come back and look at passive collection or passive identification of assets when we looking at packet captures using tools like Wireshark to find out what assets are in the network. So if you have any questions, comments, or concerns between now and then, feel free to reach out. You can leave a comment in the video, but you can also find me at the email address or linked on LinkedIn at the link there. I appreciate it. Thanks again. Take care.